Hey there. Let's take a look at the autonomic nervous system. Well, the human nervous system is divided into the central nervous system, which consists of the brain and the spinal cord, and the peripheral nervous system. The peripheral nervous system is further divided into the somatic nervous system, which is involuntary control, and the autonomic nervous system, which we will look into detail. The autonomic nervous system consists of the parasympathetic division and the sympathetic division. The sympathetic division arises from the thoracolumbar region, T1 to L3, of the spinal cord, while the parasympathetic division arises from two separate regions of the central nervous system. The cranial outflow arises from the cranial nerves 3, 7, 9, and 10, and the sacral outflow arises from the S2, S3, S4 spinal roots of the sacral region of the spinal cord. Most of the visceral organs have dual nerve supply. That is, they are supplied by both divisions of the autonomic nervous system, but the effects of one system predominates on them. Organs, such as the heart, the eyes, bronchi in the lung, and the digestive system. These organs are receiving innervation from the sympathetic and the parasympathetic system. The signals from the central nervous system are conducted to these organs via two sets of neurons: the pre-ganglionic neurons and the post-ganglionic neurons, respectively. In the sympathetic division, the pre-ganglionic neurons are short, whereas the post-ganglionic neurons are long, relatively. While on the other hand, in the parasympathetic division, the pre-ganglionic neurons are long and the post-ganglionic neurons are short, relatively. The major difference is that these both divisions oppose each other in the effects they produce on the organs innervated by them. Now, let's have a closer look on the sympathetic division. The sympathetic system is activated in the situations which involve fight, flight, and fright. For example, if a person sees danger, like an angry bull attacking him, his sympathetic outflow would increase. The effects of this increased sympathetic activity will cause changes in different body areas, such as in the central nervous system, the drive and alertness will increase. In the eyes, the pupils will dilate for better far vision. In the heart, the heart rate, the force of contraction, and the blood pressure, all three of them will increase. In the urinary bladder, the tone of the sphincter muscle will increase, whereas the tone of the detrusor muscle will decrease, as a result of which the need for urination will also decrease. As in situations of danger, more energy is required in the skeletal muscles. The blood flow and the breakdown of glycogen for glucose will increase. In the lungs, the bronchioles will dilate for better gaseous exchange. Since you won't be needing your gut working much at the time of danger, the tone of the sphincter muscles will increase while the blood flow to the gut and peristalsis will decrease. As the body will be needing more energy, the liver will increase the release of glucose. Other than all of this, sweating will also occur, and the breakdown of fat will also start. So, these will be the overall effects of the sympathetic activation. Now coming to the parasympathetic system, this division is quite the opposite of the sympathetic division, as it is activated in resting and digesting situation. Like when you are relaxing on the couch. In the eyes, there would be pupillary constriction and the lens would be accommodated for near vision. Well, coming on to the heart. The rate of pumping and the blood pressure would be normally low. The gut will be fully active. And the secretions and peristalsis will be high, whereas the sphincter tone would be low to allow the food to pass. Coming on the urinary bladder. The sphincter tone over here would also be low. And the tone of the detrusor muscle would be high. In the lungs, the constriction and secretions would be normally high. So, these would be the overall effects of the parasympathetic system. And here we are done with the overview of the autonomic nervous system. Please subscribe for more learning.